Hi everyone, this is Seema and today we will be discussing about size reduction. So size reduction is defined as a process of reducing large masses into smaller particles or fine particles. So that is the definition. Coming to the mechanism of size reduction is in four types. The first one is cutting, the second one is compression, the third one is impact, and the last one is accretion. So when it comes to cutting, here the sharp blades are used to cut down the particle size. Example for this will be a cutter blade. Coming to the compression, here there will be two rollers which will be moving in the opposite direction. So when we pass the particles through these rollers, they reduce their size and we can collect it. The next one is the impact and accretion. These two are the most important mechanism in size reduction. Coming to impact, here we have larger particles with flaws. So when we are applying a pressure of impact here, or let me say that we are applying force to this, there are cracks observed within the particles. Upon further pressure, the particles are separated. So this is the process of size reduction in case of impact. So next I will be discussing about accretion. So when it comes to accretion, we have a larger particle. When a force is applied, the particles start breaking in the edges. So this is the difference between the impact and accretion. So now we will be studying about the different instruments which are used for size reduction in pharmaceutical industry. So the instrument which we will be studying today is the hammer mill. In that we will be studying the principle, construction, working, use, its advantage and disadvantage. So this is the hammer mill, how it looks like. So the whole setup of hammer mill is made up of stainless steel. So it has different parts. That is the hopper, milling chamber, shaft, slate. The milling chamber consists of the hammer. The hammer is attached to the shaft, and we have a receiver in which the product is received. Coming to the principle. The principle of the hammer mill mainly works on the principle of impact. The impact is seen between the hopper and the particles, or the feed which has to undergo size reduction. So coming to the construction, as I said, the whole setup is made up of stainless steel. So we have hopper, even the hopper is made up of stainless steel. Then we have the shaft, we have a hammer, even these are made up of stainless steel. Coming to the screen, these are made up of metals and there are different perforations or different sieve numbers. Coming to the working. So as we can see the diagram, it is very simple with the working. So whatever the materials we have to process for size reduction, but we are placing it into the hopper. So once we start the instrument, the feed which is placed into the hopper directly enters the milling chamber. So as it is entering the milling chamber, as the hammers are rotating at very high speed. So usually the RPM maintained is around 8,000 to 15,000. So we can maintain the RPM accordingly as the type of material we have to make it for size reduction. So as I mentioned, the particles or whatever the feed we have put into the hopper that enters into the milling chamber, based on the RPM and the rotation of the hammers, the particle undergoes size reduction. They keep on rotating within the milling chamber till the required size reduction is occurred. So once the size reduction occurs within the milling chamber, the particles is easily coming out through these sieves. So once the particles are coming out, we receive it in the receiver, that is the product. So these sieves are interchangeable based on the size of the particles we need. So this is a very simple setup, it is very easy to use. So that can be the use of our hammer mill. So coming to the uses of a hammer mill, we usually get fine to coarse particles in hammer mill. And as I mentioned, the sieves are interchangeable based on the particle size we require and based on the thickness of the particles we require. Then we have different advantages and disadvantages. Coming to the advantage, as you can see, the setup is very simple. It takes very less space to place it and it is very easy to clean, dismantle and very easy to use. And coming to the disadvantage, as I mentioned, we use different sieve sizes. So when we are using different sieve sizes, what will happen is, the particle is coming out through these sieves, the chances are there that it will easily get clogged. So always care must be taken before use as well as after use. The cleaning of these sieves should be done. Coming to the applications of hammer mill, as I mentioned, hammer mills are widely used in pharmaceutical industry. for size reduction. So there are two types of hammer which we'll be using. One is the bar type and another one is stirrup type. So whatever we have discussed is the bar type, and the stirrup type looks like this. So this is very rarely used in pharmaceutical industry. So always you have to remember the type of hammer used in pharmaceutical industry is the bar type. There are two types of variants available in pharmaceutical industry, that is the fixed model and the Stokes tornado model. So these two models of hammer mill are widely used in pharmaceutical industry. So this was the overview of the hammer mill which is widely used in pharmaceutical industry for size reduction process. Thank you.